Yeah, so I'm going to give a little bit of a background talk today. It's more of a kind of a personal history, but it touches along the way, basically a walk through the recent history of IC design. Now, I've been around for as long as ICs have been around, and this will cover, my involvement in the business. So I was born way back, but only 4 years after the transistor was invented in South Australia. And a trip at age 12 to Sydney, where I met Graham Rigby at Amalgamated Wireless Microcircuits, kind of set the bit because he was making transistors and it looked pretty cool to me. So my dad was an electrical contractor and I had uncles in the electronics businesses, and that set me off on a track basically that's led me to where I am now. So there was the electronics side, and my other interest was reptiles, and I used to collect lizards, go out and catch them and do all that kind of stuff. So I educated locally, and then at the local high school down to Adelaide for a couple of years, and then to the University of Adelaide, and had a lot of impact there from the physics department. So I did electrical engineering, but actually electrical engineering didn't do any electronics, right? But the physics department did a lot. So I learned a lot by doing a physics degree on the side. And I wasn't a great student, but when it came to the final year project, I was very good at kind of building things and project managing. I then went on to do a PhD in interactive IC design. And as part of that, I went to Edinburgh for about 9 months and studied under Professor John Gray and some other professors, and an industry designer called Jim Compton. And at that stage, Edinburgh was a hotbed of IC design and CAD. So my PhD was on an integrated design system that one could use to design chips. Now, at that point in time in the history of the design of chips had just kind of come on the scene. And the way that chips were designed was basically a number of different designers in different areas. So one might do the architecture of the design, one might do the circuit design, one might do the mask design or the layout. So you've got to go from an architecture, an idea of what you want to build, right down in essence to rectangles which are used to construct the chip. So as part of that, we developed a color raster scan display. So you'll say, oh my God, so what I'm talking about is just a normal color display, right? Well, there was a time when they didn't exist, right? And this was around about the time they started to exist. And the one that we built in Adelaide was the first one that was used for IC design. Now, in addition to the actual display of rectangles for doing design, I also implemented a program that kind of takes the layout and then goes back and makes a schematic. So you say, okay, look, I've got all these rectangles. What actually does that represent? And that was done that way. Largely in Australia, I was ignored. My professors thought I was a nutcase. And it wasn't until I got to the US in 1978 at the Design Automation Conference that all of a sudden I found a lot of people doing what I was doing and interested in what I was doing. So my jobs, 1977, I took off to Bell Labs, and there I designed, I actually kind of repeated what I did for my PhD, but only better. And so I built an integrated design system that you could sit down and do everything you needed to do in the course of designing the chip. In the summer of '78, I spent a summer at Caltech, and I met Carver Mead, Lynn Conway, and on the way through Burton Ive and Sutherland. Now, all of these are if you know that, well, let me tell you, in semiconductor history, these are, you know, the figureheads, right? So I had good kind of tutelage. And right at that time, there was a revolution in IC design. Up until that point in time, the only people that designed chips were big companies like Intel and Motorola. The thing that actually I'd done unwittingly, but was kind of put down on paper by Carver, Mead, and Conway, was the notion of the tall, thin designer. And what that is a designer that can do everything from the architecture right down to the layout and actually get a chip out the door. So the idea was like an individual or a small company could do a complete chip design. This led to the creation of silicon foundries, where basically instead of being a captured foundry like Intel or Motorola, it was a place like TSMC in Taiwan who did design for anyone. Now, the way that the industry's gone is that basically the Intels and the Motorola's are much diminished in terms of the amount of silicon that's built and put on the market. So this kind of tall, thin designer approach completely took over, and I was around there from the start. 1981, I went down from Bell Labs. I went to North Carolina and taught at Duke and University of North Carolina and developed a CMOS course. Now, CMOS was the new technology on the block. It was actually really an old technology, but it had been reinvented at Bell Labs. And I happened to be there just at the right time to kind of be able to absorb all of that. We did the students did another design system down at MCNC that was based on my design system at Bell Labs. And then I moved back to Bell Labs, and they rewarded me for leaving by making me a department head. 1984, I moved up to a company called Symbolics in Cambridge, Mass. And there we designed a single chip Lisp microprocessor. We did another design system, which was a descendant of the design system back at Bell Labs. And I started to write and completed a book on CMOS text. Now, funnily enough, that took over from the book that Carver, Mead and Lynn Conway had written, which covered another technology that kind of rapidly went out of favour. And CMOS has remained the main technology from around about 1980 to now. Symbolics was a startup. I learned a lot about startups, about what to do and what not to do. And around about the time they looked like they were going to auger in, a couple of us split off a company called TLW. And what we did is a bunch of contract designs for various people, including catalogue parts for analog devices. And during the course of that, I met Ray Stater, who was the founder of Analog Devices and in fact is chairman of the board of Morse. I wrote a paper called If These Tools Are So Great, Why Isn't My Chip on Time? Now, the tools that we had were very high productivity. They were, again, single user tools that you could do everything. So I'm giving this talk, right, and at the end of the talk, I looked into the front row and there's a guy there called Jim Solomon. Now, he was the CEO of Cadence, who were the purveyors of the main commercial tools at the time. So I was quaking in my boots. So I thought, what the hell am I going to say to him? Anyway, he walked up and he said, Neil, that was a great talk. He said, I absolutely agree with you. Why don't you come on board and help us make them better? So instead of being punished, I was kind of rewarded. And that led to a lot of good things when I came back to Australia. So in 1995, I exited from Massachusetts, stopped in California and had 3 key visits. One with a Professor Tom Lee at Stanford, who was doing radio frequency chips on CMOS. Now, I mainly did digital chips on CMOS, but CMOS had the capability of doing both radio frequency for building radios and digital for building computers. And also Henry Samueli, who had started up a company called Broadcom, which is now one of the biggest semiconductor companies in the world. And finally, Jim at Cadence, and we kind of sorted out licenses to bring on back to Macquarie. So when I came back to Macquarie, I was a research professor. I had 3 Cadence design tools, and we switched over to those from the tools that I'd previously been using. And I got a Cadence consulting contract to kind of basically improve the tools. I think I ran 1 or 2 VLSI courses, and then joined the program that David had started with research on wireless LANs for CSIRO. In 1997, David and I formed Radiata. We got a contract with a Massachusetts company to do a sample system that was going to use their 5 gigahertz chips. And then we got a start grant to match that contract, and we were off and running. We produced or designed 2 chips. One was a single chip CMOS radio, and the other was a digital chip to decode the radio signals into data. And we did it with a lot of help from US mentors, friends that we'd made over the years. And we got a lot of story, and David would have a lot of stories about that too. So here's the single chip radio. It was done in 0.18 standard CMOS. And the point is that up until this point in time, radios and wireless LAN systems have been a combination of separate chips. And there were a lot, first of all, there were cost problems with that. And second of all, there were tuning problems. You kind of had to have a lab tech on the bench to tune each radio. So the way we designed these chips was that they were completely self-calibrating. And so any chip that came off the line actually calibrated itself and kind of, told you what it was going to do. In other words, there was every chip had a lab technician inside of it. So Cisco acquired Radiata in 2001, and about a year after that, our chips saw action. So the radio chip, the modem, and we used Cisco Mac for that. Cisco, the wireless networking business unit, WINBU, went on to improve that chip in a new technology and kind of put extra radios on it, and they were off and running. So around about 2003, I left and I formed a company, my own company, and I did angel investing. So I invested 3 of the more prominent companies were G2 Microsystems, which kind of was all the people from Radiata. Cisco decided shortly after I left that they didn't want any wireless anymore, so everyone was out of a job. But we rapidly reformed into G2 Microsystems, and they had their own history. Emotive was a company that read brainwaves, and Vega was a digital audio company. And in the middle of this, I funded an R&D start grant. Sorry, not a start grant? Yeah, no, industrial grant. And it's not where I met Mike, but Mike was a PhD student on that project. In 2011, I founded a company called Oz Runways, which basically does electronic flight books for pilots. By 2011, I was a helicopter pilot, and I needed help doing stuff I had to do, and I didn't want to do it manually. I'm lazy, so I wrote software to do it. And then that turned into Oz Runways, which has been the most successful electronic flight book company in Australia, and was acquired earlier this year by Boeing. 2016, I joined Morse Micro, and the objective there was doing long distance Wi-Fi. So it was diving back into Wi-Fi, but instead of 50 to 100 meters, we wanted to do a kilometre plus. And when I joined the company, I thought I was joining just to be someone they could say, well, Neil's here, so, you know, why don't you fund us? But turned out I ended up designing all of the PHY processor, which is the conversion of the digital from what it receives on the radio channel into bits. In 2022, I transitioned to the apps area because my work was kind of completed on the PHY, and I had a good wing person who took over from me, and I got interested in farm-wide Halo. Now, Halo is the name of the Wi-Fi technology that goes a long distance. So I implemented a test network at Overland Corner in South Australia, right next to the town where I grew up, at a friend's watermelon farm. And then in the last month or two, I've implemented a mesh network out at the UNSW Wild Deserts program, which is up near Fort Grey, which is up near Tibooburra. So that's like, you know, way out in the boonies, 350 k's from the nearest cell tower. And that was being done with Professor Richard Kingsford. So the Wild Deserts project is the reintroduction of extinct native species into feral cat-dominated land. And I've implemented a mesh network over about 100 square kilometres, which allows you to have remote cameras and also allows you to have access to internet and phone basically from wherever you are in that area. So here's a map. Over on the side here, we've got the homestead, and we've got links going out 14.4 kilometres at around about 5 megabits per second. So this is a first time this has been done anywhere in the world and uses the Morse technology. I might say that in addition, there's an app that I wrote to go with it, so you can do site surveys, and that basically is determining where the radio is going to go. You know, is it line of sight or whatever? You will notice that I zipped through the Osramways thing, but you'll notice the layout is kind of remarkably similar to Osramways. It's completely different code, but if you look at the similarity between flying and trying to estimate radio strength, in flying you go from a starting point to an end point and you use fuel on the way. In radios you go from a transmitter to a receiver, and as you go over the distance you lose signal as it gets attenuated. So there are complete parallels between, you wouldn't think this, but there are complete parallels between flying and radio. So here's some of the units at Wild Deserts. On the left is one of our stations, so it goes up about 5 metres, and there's a high gain antenna up on the top. And then there's a solar panel and a battery. And then the one on the right's a little short antenna right on the ground, right? And that, again, it's got a solar panel and a battery. The energy usage of the Morse thing is less than 2 watts, right? Which is about at least 1,000 times lower than a cell tower and more than 1,000 times less in cost. So here's so there's a bunch of cameras here, but the one on the right at the top, this one here, I don't know if my pointer shows up. That's our cameras, and then you can see the station in the back there. Whoops. Oh, what are we doing here? So here's some videos from these remote cameras, right? So that's Dad Emu and his kids from all his wives. I don't know if you know that. I didn't know that until I took the video and said, "Oh, Mum's out with the kids." There's a goanna. So this, what this site is looking for is looking for warmer pythons, actually. Come on, go, baby. Trying to get to the next slide. Why won't you go? Not playing? Oh, what's this? Is the bearded dragon? So now you see where the title for the talk comes. At the beginning of my life, I was interested in reptiles and radios, and at this stage of my life, it's exactly the same. Hang on. Now somewhere here we've got, what have we got here? Oh, of course we're looking, oh, there's the Wama python. He's not moving. Oh, damn it. Here's a feral cat. So we logged the feral cats. And then finally, the last one. Oh, come on. Jesus. Oh my God. So this is one caught by the camera at Overland Corner in South Australia. All right. So I didn't really talk very much about semiconductors or, wait a minute. Or actually what I've done, but this is a summary of what I've learned in the last 70 years. And it kind of parallels, I guess, my interest in the semiconductor industry. So if you notice, you know, what I've actually done is just do the same thing repeated again and again, right? So, you know, that's the plan that seems to work, right? Second thing is there's many times where I didn't know what I was going to do, right? But for some reason, you know, you just start at the corner and start painting towards the other side of the room. Many times we were told we didn't know what we were doing, right? And we basically ignored it, especially in the wireless Wi-Fi area. One important thing for Australians is to get calibrated and spend time overseas. In other words, figure out how good you really are. Are you, you know, top of the notch on a world scale or just Australian scale? One of the things that I'm a big believer in is new products. If you can't kind of basically proto it in a day and you can't kind of get a good version in a month, then you can't productize it in a year. In other words, if the thing's too complicated, just to get it off the ground for a start, it's not going to work, right? One of the things my father told me, right, and it's probably common, is that with wealth creation, you can dig it up, grow it, or invent it. And that's particularly where semiconductors come in, because as an engineer, you can go home at night and get a CAD tool and start basically creating stuff. A good dose of paranoia is good. If you search for something that you're doing, in order to find it, and you don't find it, you haven't looked enough. You haven't looked. The old adage, equity is gold, cash is king. Never trust an intermediary between you and your customer if you're developing new products, because their interests are not your interests, right? And secondly, if you get something from a customer about, oh, look, I'm interested in this, but if you could just do this, usually the intermediary doesn't understand your technology well enough to act for you. Empathy is great because it allows you to look from the other person's point of view, and it just helps resolution of various problems. And finally, the customer is always right, of course, except when they're wrong. All right, that's it.